Okay, this is Precalculus, Unit 2, Day 1 notes for my students that were absent due to volleyball or other things today. So we're now going to be graphing sine and cosine, and we're going to be using the unit circle. You are welcome to still use your reference angle table if you'd like, but we are going to be using the unit circle. So everyone got a copy of this today. And you'll notice on the unit circle that not only do I have degrees, but I have radians as well. And then that's my cosine, that's my sine. And the one you got in class today has a little reminder of cosine is my x, sine is my y, and what tangent is and cotangent. And you will not have this part on your test. So on your test, you will get the unit circle. It'll look just like this without this little flap of information. So in terms of graphing it, it is cyclical. It repeats. If you think about the fact that the circle, as we go around, right, everything repeats. I go around one time. If I go around again, it's all just repeating. And so that's how my graphs are going to be. So we're going to graph typically one cycle of it, sometimes more, sometimes less, but typically just one cycle. And the first page of the notes is pretty much just getting an idea of what it looks like. And so we graphed one cycle from 0 to 2 pi. Since the unit circle goes from 0 to 2 pi, that is what we graphed. And up here is in degrees. You can actually look at the unit circle and get the radians, or you could do it by hand. And then what I'm graphing on the x-axis is radians and the y is sine. So I transferred all of these radians into decimals. And we don't normally like decimals, but in this case for graphing, we kind of want to see where it is. So just to show you where these numbers came from, like 1.6, there goes my 1.6 came from dividing pi. Oh, it's not going to zoom. All right, so it came from dividing pi by 2, and I rounded. So that's where I got these numbers. I took the radians, so for example, pi over 2, and then I rounded that to 1.6. So that's all I did for all of these, is put the radians in the calculator and get some sort of decimal that I can graph. And then the same thing with this. I find it easier in degrees, so you make sure your calculator is in degrees. But instead of having the sign be things like square root of 2 over 2 or square root of 3 over 2, I want them in decimals so I can graph them. So for example, 0.7, all it is sine of 45, and then I round it, 0.7. Sine of 60, I rounded, 0.9. So that's where these numbers came from. And then we just graphed them. So here's my x of radians, my y is sine. It's not super neat because it's not on graph paper, but this shows you, right? It starts at 0. Here's my maximum at 1, goes down to my minimum at -1, and then goes back to 0. So sine is always between -1 and 1, and you saw that from the unit circle or from the reference angle chart, but it's easier to see definitely here when I put them in decimals to see that my sine only gets up to 1 or -1, and it's never any bigger than that. So the 4 important points to remember from here are those x and y axis points, right? 0, pi over 2, because that's my max, pi, because it hits the x-axis, 3 pi over 2 is my minimum, and then back to 2 pi is my 0. So those are my really important points that I need. Typically when I graph, I'm not going to have all these in-between points, but I am going to have these 5 points. So you can see my domain, my x values go from 0 to 2 pi included, so that's why there's brackets. And my range goes from -1 to 1 included. Cosine is the same thing. So actually, the first 3 rows of this are the same as sine, right? It's degrees, degrees moved into radians, and then radians in decimal form. So these first 3 rows are the exact same as above, except this time we're doing, and this says y equals sine, it should say y equals cosine x. So cosine x, same thing. I'm just going to put, for example, the cosine of 60, and that's where that 0.5 came from. Or the cosine of 120. That's where the -0.5 came from. So I'm just getting values in decimals so I can graph them. So you can see that this one, I have those same super important points, right? So 0 is my important point, that's my max. Pi over 2 crosses the x-axis. Pi is my min. 3 pi over 2 crosses, and then 2 pi, again, is my max. So those are my really important points. We're not going to normally have all the ones in between. And I have the same domain as sine, 0 to 2 pi. I have the same range, -1 to 1. So again, that's just an exercise to see what it looks like. We are not going to graph it like that normally. We are just going to graph these 5 points. So in terms of graphing, my transformations are the same as they are for any other function, for if you were doing absolute value or parabolas, square root. This number in front is my amplitude. That's how high or how low it goes, my A, and it's always positive. I might have a negative in front, but that negative means reflection. My amplitude is positive. This B is how I find the period. I find the period by taking 2 pi divided by B. So I use this to find the period, but it's not my period. And then whatever I have here in parentheses, x minus c, or it could be x plus c, is my phase shift. That's how far right and left I'm going. And that's the one that's the opposite of what you want to think. If it's minus, I'm going to the right. If it's plus, I'm going to the left. And then this last plus d out here is my vertical shift, which is how far up and how far down. And that is what you would think. If it's plus 2, it goes up 2. If it's down 2, it's minus 2. So you're going to need a new center line, by the way, if you do a vertical shift. So amplitude is my A, how far up and down I'm going. Period, I use the B to find my period. Phase shift is this piece in here, and it's either going to be to the right or to the left. And my vertical shift is that D, and that's up or down. So now when you graph, you got to have the basic curve in mind. So that's what we did on the first page, right? So my basic sine curve looks like this. And again, we care about these 5 points. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Starts at 0, max, crosses the x-axis, down to minimum, back to the x-axis. Same thing here, same 5 points. 0, pi over 2, pi, 3 pi over 2, 2 pi. But cosine starts at our max, goes down to our min, back up. So make sure you have those in mind while you're graphing. It's always helpful to do a small basic curve of one of these before you graph. Period, so how long does it take to go one cycle? That's what period is. One cycle being 2 pi, right? So my regular period's 2 pi. My cycle's not 2 pi. My regular period's 2 pi. This is my cycle, right? It goes up, down, and that's going to keep repeating. If I kept going past 2 pi to 4 pi, I would do it again. Up, down. 8 pi, I'd go 2 more times. And we will talk about these as we graph. But the other thing to keep in mind is what reflections look like, right? So reflections, if I have a negative in front, so normally my sine curve goes up first and then like this, but reflections, it goes down first, then up. Normally cosine starts at 1, but if it's reflected, it starts at -1. So also keep those in mind. All right, so how to graph these. We said amplitude is always positive, but you should mark down if there's a negative in front so that you remember to do a reflection. So my amplitude is 3, and I don't have a number in front of here, so my period is my normal period. It's just 2 pi, right? B is 1, and that means there's 1 cycle. So I know I'm going to see this 1 time. So the way to graph it, go to your period, which for this one is 2 pi. Divide it by 2. That gives you pi. Divide that by 2. That gives you pi over 2. Now you know you're going by pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Right? And if we reduce 4 pi over 2, we get 2 pi, and 2 pi over 2 is pi. So those are my 5 points, including 0, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi. It's reflected. So remember my normal sine curve, so y equals sine x looks like this. It goes up and then down. I'm reflected. I'm going to go down first and then up. And it helps if you put the points in. So before you graph it, and I realize it's already graphed, put that point in, go down through the x-axis, maximum, back down. I would put those points in before you start, and then you're just connecting. So, and again, notice there's 1 complete cycle between 0 and 2 pi because my b is 1. So right away on this next example, b is 2. So before I even graph it, I know there's going to be 2 cycles because my b is 2. So this one has no reflection. My amplitude is 3. Oh, I'm sorry, I didn't show on this one. Because my amplitude is 3, instead of doing 1, like normally, right, my sine curve here is just 1 to -1. This one goes from 3 to negative 3 because my amplitude is 3. All right, so on this one, my amplitude is 3. To find my period, we said 2 pi over b, right? So 2 pi over b is my period, and b is 2 from right here. So 2 pi over 2 is my period, and that's pi. What this means, I always want to graph to at least 2 pi. So I know I'm going to see one cycle, right? If you cover this up, one cycle between 0 and pi. But I always have to graph to 2 pi, and that's where it says, so 2 cycles. I'm going to see 2 cycles between 0 and 2 pi. So to do this one, you got to put them both in. You're going to have your 2 pi, but then you got to cut in half. So this little piece right here, the one cycle, right, my period is pi, I've got to have those 5 points, 1, 2, 3, 4, 5. So again, to find them, you have pi, cut pi in half gives you pi over 2. Pi over 2 in half gives you pi over 4, and I know I'm going by pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And again, I put the points in first and know what it looks like. So I know for this graph that it's sine. So just like above, y equals sine x. I know it looks like this, but I'm going to see 2 of those. And I'm going to put my point here. It's not reflected, so then I go up to my max, down to my 0, minimum, back to 0, max, 0, minimum, max, and then connect your points. All right, let's do a cosine one. So I look at this, and I see 1/2. That means I'm going to see only half a cycle between 0 and 2 pi. My amplitude is this, which is 2, so there's my 2 and negative 2. My period is 2 pi divided by 1/2, which is 4 pi. So I still need to go out at least one period. I'm not just going to go to 2 pi. If my period is bigger than 2 pi, I got to go to at least one period. So I go to 4 pi, cut that in half, which is 2 pi, cut that in half. So I know I'm going by pi. 1 pi, 2 pi, 3 pi, 4 pi. So those are my important places. And it's cosine, and it's not reflected, right? So y equals cosine x looks like this. So I'm starting at my max, going through the 0, going to my min, going to the 0, going to my max, and connect. So the only other thing we need to cover is vertical phase shift. And I'm actually going to do that by hand, I think. Because I would like to see you at least see one from the beginning without just watching one I've already done. So we're going to do the one that's on the paper, but we're going to do it from scratch. So negative 3 sine x minus 2. And again, we care about the amplitude, the period, and the vertical shift on this one. So right away I see this negative. So I'm going to write reflection so that I don't forget. My amplitude is 3. On this one, right, my b is 1. So that means 1 cycle. So that means my period is 2 pi. If b is 1, it's my normal 2 pi period. And I'm going down 2. All right, so when I graph this, I have to make a new center line, right? Normally I would go up 3, down 3, but I said I'm going down 2. So instead of my center line being here, my center line is now down here at negative 2. I had to move it down 2. It's not the x-axis. Normally my center line is the x-axis unless I have a vertical shift. So now I'm going down 2. And from here, I'm going up 3, down 3. So 1, 2, 3, 1, 2, 3. So I'm going between negative 5 and 1. And this is my center line. I have normal periods, so 2 pi, cut that in half, pi, cut that in half, pi over 2, 1 pi over 2, 2 pi over 2, and 3 pi over 2. Now, this one is sine, so we know normal sine looks like this, right? y equals sine x. But we're reflected, so we're going down first, and we're starting on our new center line. So instead of starting at 0, we have to be on our center line. So starting there, down to our min, back to our center line, up to our max, back to our center line. So it goes like this. So notice that it's not exactly touching the points on the x-axis because that's not my center line anymore. My center line is down here and it is touching exactly through my center line. So that is how to do vertical shift. If you have any other questions on this, I know this is kind of a long video. It's 15 minutes, but it's not long compared to how much time we spent in class. So please, if you have questions on this, please come see me for help on Tuesday morning before class, because we're going to keep going with this afterwards with phase shifts and more graphing.